All right. So, hello everyone. Thanks for joining. A little bit of a hiccup there in terms of the stream for a second, but we're all good now. So, first of all, thank you for all being here. Very excited to go into this topic. I think it's very relevant, and we definitely have a lot to go over in some ways. And we're gonna also make sure here, Rex, there's nothing you need to do on your end, but I'm just gonna make sure things go well. So, Sean, why don't you go ahead and introduce yourself? We'll do a round of introductions here as we get into the topic and kind of the whole flow of it all. So, Sean, kick us off.
Sure. My name is John Sosefsky. I am a hardware development engineer at Amazon. My focus is on innovation and automation for fulfillment and logistics. Everything between when you hit a button to order an item and it getting to your door, essentially. And then before that, I did manufacturing engineering and product development engineering at Boeing, focused on payloads, structures, and propulsion.
Mm-hmm. Cool. Uh, Rex, would you like to go ahead and introduce yourself as well? Oh, I think you're on mute. For a second there. Just be sure on the streaming one, not the meet. This is a classic stream circumstance of muting the microphone, unmuting the microphone. It's like it will never get old. Is it on mute even uh, on the Google Meet? Y- yes.
With the American Concrete Institute, retired in July. I continue to do some consulting work for them and others.
All right. Cool. And as for myself here, so uh, I I'm based in Austin here, and my background's more actually from a software and user experience standpoint. But the focus I've had has been on the AEC industry and pre-construction particularly. So I just find lots of technology implementation, having a lot of its own kind of set of responsibilities in terms of how they fit in. And so I found a lot of my focus being there. As for one with method and build, that's another the project itself as it comes to uh, roles that data has in the processes and decision making functions. So quite a few things there I'm doing, particularly on the building product side. But all that we're seeing here on the media side of things is much broader and focuses on many relevant things to do with, where we are today with a lot of the what maybe the future may hold. At the end, we shape the future. It doesn't just happen to us. And so hopefully conversations like these help us reflect and point out maybe things that might seem more likely in some regards. So we've been chatting quite a bit beforehand, right, Sean, Rex, on sort of what this is all about. And we both of you bring in different insights. Roshan, you've more recently, with the company you're with, lots of implementation there, and how we envision this future for how we work around robotics and how robotics works around really us and our spaces and what we can provide right now versus what we can build for the future. Um, it's all very relevant, right, for sort of what we consider are important things to design requirements. And so let's maybe get kicked off on this whole topic and share a bit on what kind of experiences you've had in terms of what you look out for uh, in terms of implementation, but also generally on the scope of what does it even mean to look at robotics? Like, tell us a bit about that.
Sure. So I've done robotics through manufacturing, now logistics, and logistics is a wide field, right? From fulfillment to um, fulfillment, the different uh, value streams in fulfillment. But the things I look out for are what are people currently doing? I mean, our job is looking at improving safety, improving labor. Um, so looking at in these different processes, what can be automated? There's a ton of different constraints, even within 1 mile of the logistics value stream. Um, you might do trailer unloading, and that has a very specific constraint in that it's inside a trailer. That's something that humans are very good at. Replacing that with automation is very challenging. And so you might look at things like humanoids. We aren't yet, but as they develop, maybe. Then as you get into the building and your constraints are reduced, you kind of have a little more freedom in the type of automation you look at. And Rami and we talked about this a little bit. You can start to balance things a little more. Do I look at humanoids and trying to replace people 1 to 1, or do I look at specialized robotic systems, industrial robotics, 6-axis systems that are maybe they're more specialized in what they do, but maybe I get more throughput. So there's a lot of different variables, and it really differs by use case.
Absolutely. Well, I mean, the use case part is actually pretty critical, right?
Yeah,
I mean,
the most critical.
I mean, actually, for that, there's something I found that we'll visualize here. So essentially, when we look at robotics in terms of even just their cost, for one, there is the own cost of developing the machine itself, and they're not always in touch with each other, right? So like there could be robotics companies out there envisioning the use cases. Obviously, it also comes from their own talent, I imagine. So the recruitment of who gets to be part of the companies in terms of where they see the North Star for where the implementation is. And so a lot of times it's hopefully the development went through with the right partners as they went through testing and then figured out, okay, these are like viable partners we can have. I mean, fundamentally, just looking at it from the business standpoint of robotics companies are probably in this business to get a longer term engagement with their clients, right? And hopefully sign on multi-year contracts and keep them within however ecosystems are even considered, right? Well, maybe we won't dive too deep into that because it might be its own conversation. Um, but fundamentally it comes down to like asking the right questions around like, well, what are the design considerations we should have. um re- Mhm. Mhm. And so in the context of the um well, let's just say, well, cost, Rex, we actually talked about cost quite a bit earlier. And we were talking about like different business models that exist right now and maybe could be implemented in the future. So, what are your perspectives on that front in terms of business model and sort of how they envision short, long term kind of deployment and how, I don't know, the OPEX, CAPEX consideration too for how this gets invested into the client and the use case scenario?
You were talking to me, Rami. Um, one of the in
I
the
think,
either one. I'm sorry.
yep, go on. Sorry.
Okay. Um, in the construction area, the humanoid robots, uh, at least from my perspective now, looking at it over the past couple of years, I'm not so sure they have a direct application within the construction area because a lot of the things that we do are so specialized or require such specialized end effectors that it may not make sense for the humanoid application to be used. And then in that case, then you're going to have specialized applications. It probably makes more sense from a business case to have more of a user, a support system. So a rental on the robotic system is probably going to make more sense. For example, one of the printing companies that will do a layout for construction. They actually supply the staff as well as the robot. The robot itself is not for sale. They're a robot as a service company. So I see robot as a service is probably a big advantage for some of the specialized robots that we have.
And so in this case, you're even talking about it from a construction standpoint. And
Yeah,
so in that case, like when we talk about designing for robotics, we are actually here looking at it from many angles. And
hmm
in this case, it could be its final implementation, maybe say in a more, let's say, finished product use case scenario. But in this case, its operations are in something that's still in development, right? So we've seen it with, let's say, Icon as an example for 3D printing, where they kind of moved from these gantry systems to something that uses more of the robotic arm plus a gantry. And so there's this interesting hybrid. And so at that point, the design question becomes is how do you maybe design the site to accommodate the machine so that you can print well safely, first of all, and then from a risk standpoint that you're actually printing on the right layout. If the lot is a rectangle and you orient it the wrong way, do you end up with a crooked, you run into the
hmm
neighbor's lot, sort of scenario. But yeah, and so maybe let's dive a little bit deeper on that front. So, and Sean, you mentioned this as well when you talked about designing the spaces. And what I mean by designing for spaces is how do we accommodate the needs, or the requirements that the robotics have. And in this case, we can definitely not think just humanoids, right? But there could be
Yeah.
arms, there could be different systems. And from these different form factors, we talked about like sort of how to review the tolerances that exist. And so, is it about designing the space to accommodate the machine, or is it the other way around? And more often than not, it's kind of what is more feasible, right? That makes sense. But we always have to start from sort of like the requirements standpoint. And so tell us a bit about that because you've had that experience. You've been kind of understanding like sort of what we look for in terms of the
Right.
tolerances and things like that. Yeah.
Yeah. And I will say I think I also support what Rex said, at least for the moment. The extent of processes that I currently see in logistics that could be handled by humanoid robots that currently exist is pretty limited. For us, throughput is king, right? You need to get stuff quickly through a building. People want their items in a day. They don't want it in a week. Um, so your requirement really becomes it largely becomes throughput. So processing enough items in a given space that I can. And it's really the same for manufacturing in my experience. Um, so yeah, when we design end-to-end highly automated systems, we kind of, or at least I start by breaking a building down into what I think are the most critical process paths. Um, Understanding the size of individual cells, I guess you could say, for a process, and then you'll have an entire system, right? So if I'm building, what's an example? If I'm building pallets of boxes, I'm not building one pallet. I need to build 400 pallets, and maybe each cell does 6 pallets, 4 pallets, or 20 pallets. I need uh, multiple cells. So I'm designing my space around that. I guess my most critical automated processes, and then kind of putting together the rest of the puzzle. Um, and I'd say that's the easier side of things. I talked a little bit earlier about say trailer based processes where you don't have that flexibility, and then you're really constrained by the space you work in. I no longer can say, oh, I have all the space available. How much can I fit in there? I have a little cube that I have to fit this stuff in. How am I going to accomplish that?
Well, I mean, fundamentally, and even that, I mean, that's something we're looking at right now. So, on the screen at the moment, we're looking at an example of a robotic arm. So in this case, Doobot. And what's interesting here, I mean, when we consider design requirements, we kind of have to look at what the tolerances are, like you said. And so we can look at sort of what the range of motion is and sort of the working environment in terms of, how
Right.
cold or hot the space can become.
Right.
What I
A
find very,
typical cobot.
yep. Well, in this case, it becomes even more interesting is where we consider I mean, in this case, these are definitely look more for indoor and controlled environment operations, right? And so it kind of gets interesting, but like if you think about, say, working environment is in this case they're in Celsius, but 0 to 50, right, or 32 to 122, and you sometimes might consider that if you're doing this outdoors, like it does potentially get colder than that. Hopefully not hotter. If we're in a state where we're hotter than 122 degrees, that's pretty rough for sure. Um, but when it comes to electricals too, right? So like having the right electrical system and wiring. Um, and Rex, this applies to you as well in some ways, for the fact of what do we consider in electrical systems that should be accounted for in terms of even how we review this with say our consultants, and if we work with the electrical team in terms of understanding how they assess these requirements. I mean, are we seeing it to a level now where they're more proficient electrical team companies that where their teams understand sort of the nuances around the consideration, or are we finding this to be an expertise that comes from the manufacturer and becomes a consultancy more so on the machine itself?
Honestly, I'm not sure this would be, if you're talking about having a cobot or something um, within a facility, obviously the designer is going to have to worry about getting power to it. And Sean, do you wind up having just a bus system overhead that is adaptable to various layouts, or are you fixed with the power supply to these various systems, or do you have battery operated systems with swappable or chargeable systems?
Yeah, I mean, we are, most facilities are at a high level power constraint, right?
Mhm.
You can only accommodate so much. And we have done updates to like process path automations based on power requirements. Like generally a 6-axis, the power requirements are greater than a 3-axis gantry. So we have broken down problems and said, hey, do I really need the dexterity or the capabilities of a 3-axis when I'm just picking up and placing things? And the answer is usually no. And it is an enabler for larger scale automation in a facility. And then there are times where we've looked at batteries, but then you have to charge batteries. There's challenges that come along with using batteries versus hardwired connections.
Mhm.
But it's certainly a constraint. You can't just throw 100 6-axis arms into a site willy-nilly without considering the power requirements.
So we've been talking about, for example, distribution centers here, but if we move on and get into areas where we're interfacing more with customers, whether it be in a hospital or an airport, you can't have the power supply out there. You don't really want people interfacing with the large robotic systems, but you could have these cobots or the mobile, the AMRs, the autonomous mobile robots rolling about. In fact, Rami and I have been talking about the application of wheelchairs, autonomous wheelchairs within airports. They've become fairly popular. In fact, the airport where I live in Detroit has had AMRs running around transporting passengers for a number of months. So you get into the power supply issue there. They have to be battery operated, but where you have to accommodate the design of the building and have a special space for charging of those batteries, because there could be a safety issue, not just from the power supply, but also for fire protection.
For sure.
In case you have a battery overload condition. Yeah. And then one last thing before I'm just doing a kind of a thought dump right now on this issue of power. ASTM has a committee, F45. I'm not sure where this work product is at right now. It only started in August, but they're looking at the standardization of wireless charging systems for AMRs, which could have an impact on the design of the building as well. So if we're talking about these AMRs or whether they're robots helping robots within a hospital, all of them have these various power battery charging issues that have to be dealt with in the design of the building itself.
Mm-hmm. Yeah, and we have also been looking at AMR-based industrial robots, because it kind of, if you have humanoid robots on this side, one side, and very specialized industrial 6-axis cells on another side, AMR-based industrial robots kind of bridge the gap where humanoids probably require very little physical space consideration, and your specialized cells require a ton of consideration. That's what you're designing for. In the middle are your AMRs they require some consideration. Obviously, I'm not going to get an AMR upstairs like I might a humanoid, but it's mobile. So yeah, we're looking at that full range, and it is challenging because there are pros and cons of everything within that range.
And oftentimes it's also, I mean, this information would probably live somewhere that has to be considered on how it integrates into some of these tools that we use for design as well. So how do we get these parameters and these variables into systems where the logic for how we consider them are defined? And I think it gets even more interesting there, right? So, I mean, Rex, at this point, as you look at, I mean, standardization has always been a good way of kind of just aligning efforts. And as the industry, as we've seen it with electric vehicles, right? The large auto manufacturers finally came to a conclusion that we don't need to have adapters, hopefully, and that we can use the same plugs. And there's a more cohesive network that can be used with each other. And so, similarly for robotics, I imagine that we can't all be proprietary. And I mean, ecosystems for different companies maybe might exist, but certain things might be universal. And so, generally, based on your experience, even with these associations for how they keep up with it, so how are you seeing the interaction now between it being a committee issue versus, public hearing and sort of engagement? Do they end up having? Are you seeing there being a behavior where we're getting designers to get to interact a little bit more with policymakers and those lobbying for certain decisions in any particular way?
The design standards like that we're discussing now, those will be they'll be created on a voluntary basis. They're not really created from the lawmaker's standpoint. They can be incorporated into the laws from statutes by reference, and that will happen, of course. But to generate the actual standards, that's really a voluntary process that happens through consensus, at least in the United States. So, for the example of the ASTM committee that's working on the real-time, wireless charging stations, that'll be committee members comprised of industry members, whether they're manufacturers of robots, they could be architects, they could be engineers, they can be users and owners, but they will generate a consensus document based on the state of the art, and then that will basically become the standard for future use. I don't know, is that where you were
Well, it's
curious?
yeah, the curiosity more so just stems from kind of maybe giving a perspective around if there are any differentiations in the approach in this instance, given all the really efforts, especially in terms of capital that's going into robotics to ensuring a path ahead that's somewhat more de-risked for some players, and just like as a system, right?
Mhm.
And so, yeah.
The standard that I was discussing, I just alluded to for the mobile charging stations. That's an ASTM committee, but it's being generated. The document that they propose will be generated in conjunction with another organization called Enterprise Singapore. So, and you could have additional organizations. It could be a European norm that comes into play as well. But I haven't seen any indication that the European organization is involved yet.
Well, we'll see, Evan. I think with in many ways it will come down to being a conversation around energy as well.
Mhm.
Because I mean, right now it seems like there's an issue with keeping up with these data centers. And so like if we imagine just at this point too, all the points made earlier, right? Is it something that you have on-site storage and energy management systems, battery management systems that kind of work a little bit better to offset maybe demands on the grid, and then whatever is on-site, renewable, things like that. But yeah, I think a lot of it is taking shape. But I mean, Europe is very well known for its heavily kind of mandate-based kind of environment, and so it becomes interesting then to see the approach there. Um, as long as it's USB-C like, in terms of something that's an open standard in that regards. Um, yeah.
We
Hopefully.
do, on this point, we do, at least in our use case, request standardization where possible. At our scale, uh, it doesn't make sense not to. And that's across various, that's not just charging, it's integration into existing systems. We're talking about AMRs. One of the challenges for us with AMRs is integrating AMRs into our systems that already exist that are, company owned, that trigger an AMR to go do something. Um, so it's not just batteries, it's batteries, it's integration into other physical equipment, conveyance is a good example, as well as software systems.
Hmm. Yeah, it's on the software side, just like we're seeing with AI right now, the proliferation of tools and interfaces that people are developing. I can only imagine it extend to robotics as well, in terms of like the application layer for robotics, and it ends up being kind of digital physical. And in many ways, I've seen it framed as phygital. Like the word of blending the two seems to come from many ways. Um,
Yeah.
but I mean, the industry topic is probably it. I mean, right now for whoever is still part of this call and is still tuned in, something I thought might be interesting to get some engagement with all of us is to maybe get a pulse check here for anyone who's participating, to maybe share like what are the industries that come to mind as you consider robotics. Because right now we talked about it from a very kind of manufacturing standpoint. We talked on certain use cases and like operations, and so in this case with airports. But I'd be curious to kind of see from, we see there are quite a few joining us here. On what do you think that, what are the industries that maybe highlight a little bit more? So, um, and this is also open to us to maybe chat a bit about and bring our kind of personal curiosity to till we get some responses in here. So, mm, Sean, Rex, and I'll go ahead as well and share. But what are the kind of industries that kind of speak up more, are more highlighted in your view, for where you're kind of excited to see their implementation and just general application?
I mean, I would immediately say construction. We've talked about construction quite a bit, right? And I think there's been automation in the modular and prefab space, but outside of that, very little automation. And the question is, how do you get there? To Rex's point, and like I said earlier, I don't know that at, at the moment humanoids certainly aren't the answer. Folding a towel is not equivalent to building structures and doing electrical and plumbing and hanging drywall, right? And hopefully it will eventually get there, but I think there's a ton of opportunity in the construction space because it is high labor and, you know, high injury, and those are the two things we try to address.
You know,
Yeah.
the construction site presents so many hazards from a walking standpoint. It makes one wonder if a humanoid form factor is the right approach. Something with a quadruped might be better, at least from a stability standpoint. If it does trip, it's not going to fall over and it's not going to injure somebody when it does. But it doesn't mean it can't be something that's more animal-like in its movement, but then has a cobot mounted on its back rather than arms, or it could have multiple cobots. So I think we're going to get to the point where we have more universal machines. They just may not be humanoid machines on construction sites. There are a lot of specialized systems out there now for things like applying drywall or installing curtain wall connectors around the perimeter of a building, or doing surveys, but they're pretty much wheel-based systems, which don't necessarily lend themselves well if you've got a
Hmm.
slab form covered with uh, conduit and reinforcing bars and
Right.
embedments.
Well, and Rami and I talked a little bit about that. I I think or I think you jokingly said, "Oh, a humanoid with 8 arms," and I said, "Well, that's not a bad thing.
Yeah. Yeah.
Like there are things that humans are good at. We have fantastic dexterity. We're able to think on our feet, so to say. But there are a lot of things we aren't good at because we just have two arms and two legs. So the maybe the development of quote unquote humanoid robots is, I would hope it's something that is better than humans to take advantage of the things that we currently lack in. And one of those things is stability and long reach or the ability to handle many things at once. I think there's a ton of opportunity there. Um, Now, when will we get there? Fantastic question. I'm waiting for it.
Yeah,
Yeah.
this is the hand is a great end effector, but it may not be the best end effector for
Exactly.
something like construction.
Yeah.
But moving on from there, Rami, you'd asked about other applications. We're seeing a lot more interest in some applications for, especially in the medical field, with
Hmm.
the need for staff to help with things like transport supplies, including medicine, to patients in rooms, as well as just handling the patients themselves. Whether the devices are necessarily humanoid, they could be assistive devices that would, maybe a wearable robot that helps the workers when they have to do something like
Hmm.
adjust the patient's position within the bed or to pick them up. Humans are not going to be too keen on being picked up by a robot, but they would be positive to being picked up by a human that's being assisted by a robot. So it goes back to kind of Sean's allusion to having the AMRs, the autonomous mobile robots, is kind of the interface between the the uh, the six-axis robots on one side of the aisle and the humanoid robots or the humans on the other side of the aisle.
Yeah. I mean, at that point, we're touching on what will universally be a very, uh, I would say, relatively subjective issue to some degree on the cultural aspect of it. Because even for me, I always associate for some reason, just because of how we've seen Japan handle the aging population challenge with implementing robotics in various ways. And so, like, the first thing that comes to mind is at that point, how have other cultures adapted to this maybe till now as a way to set some precedent potentially? Um, but then, yes, it very much becomes just from a psychological well-being factor that human to human interaction always gets to be important. And so, what is the right balance to strike in this case to maintain the need there is for supporting a larger segment of an aging population? And so, um, I don't think everyone's getting their parts replaced to be all young again. So, in that sense, I think it'll definitely it'll be pretty interesting. Um, well, in that sense, we're also kind of getting closer to the hour, so we don't want to extend this in too many spirals in some ways. But we touched on very interesting components about sort of how we determine the specifications and how we look at tolerances. But then the regulatory side, right, and things like ASTM's committee development, and that there are motions in place to be more proactive, I would say, I think, because I imagine that this is a phase that requires some proactiveness in terms of how we want to shape things. And in this case, we're talking to an audience where the clients are forces in the world to bring in spaces for our cities and the built environment in general. And so, what are the demands for the occupants that we need to address to improve their experiences and ensure things get, to be better for quality of life considerations? And so I think from that standpoint, it will end up opening up many opportunities for how we consider these as a solution. And it might just take a lot of experimentation as well. It was kind of interesting to see. So this tool called Fabrica, um, the fact that you're going through thousands of iterations before you figure out what's the right system for what your needs are. I mean, that's a lot in some ways, right? If you think about it. And so for any designer trying to think, oh, how do I need to accommodate the space programming for humans to interact safely when robots exist doing these functions becomes a very interesting topic where to make that job easier is that the documentation is out there and we just need to use them and iterate our own modeling and design tools and environment to make it easier for us to navigate thousands of iterations, but making it feel like it was just two or three. So I think that's the beauty of a lot of the automation and tools is to make us feel like we haven't had to go through that many, but we did, you know, and so that'd be the exciting part for sure. Um, well, as we get towards the end, any final thoughts any of you want to share about what are priorities in this whole topic and what you might want to pursue or encourage someone who's maybe researching this topic a little bit more or trying to inform themselves more around how they can pitch clients new experiences and ideas using such systems. What would might be some insights you consider good?
I mean, I think it all comes back to use case. Um, like you said, we talked about requirements and standardization and regulations. Um, I always tell our young engineers, deep dive your use case and the answer will come to you essentially. it's it's our job to find a balance between capability, uh, cost and return on investment, space utilization. Um, Once you deep dive those things, I think you figure out where in that range of humanoid to AMR based industrial robot to very specialized industrial robotic cell, you find what's right for you. Um, my suggestion would not be to would not to focus on one of them to begin with. Otherwise, you kind of back yourself into a corner.
From the construction standpoint, there are so many different things that are being developed from the construction side to at least try to get us back on an increase in productivity rather than the flat line we've seen for the last couple of decades. I think all of the designers in the construction teams particularly are looking at any innovations that they can incorporate, but of course they have to look at the ROI on whether they can implement it. A lot of it's going to be driven by the owners, but then when we get to the design side, that's where the owners really are going to have to start asking for things that can make their operations more efficient, because the OpEx is going to be a major part of the cost in the future. So especially something like the distribution centers or like the hospitals or like anything like an airport, anything that can be done to reduce the demand for the labor on a facility like that has so many people working as well as using the facility. It's going to be not just the owner and productivity, but it's also going to be a safety issue. So,
Yeah, yeah, the
but this,
safety one, I imagine it being the very high price. At that point, it is about just like that's in this case, the analogy to safety, I guess, like the military, right? Like the goal is never to harm anyone. And so, like,
right.
if a mission or something calls for someone to put themselves under high risk, that might be a good place to start. Let's like optimize for those scenarios, and whatever is of high risk, can we tackle those in that sense? So yeah, 100%.
And of
Um,
course, the AMRs we haven't really discussed here are the autonomous cars like Zoox and uh, Teslas and
oh yeah,
Cruise.
that's a whole episode. Might be a whole
Long
season.
haul trucking,
Yeah, long
huge
haul trucking. Right.
opportunity. Yeah.
So
Uh,
safety, safety, safety.
all right.
I mean the big for a future reference. So as I even we got this call to happen in the stream and this topic, as I dive deeper and talking to others who are either investing in the area or are developing solutions, the one thing I find is interesting, and maybe in the future there'll be a stream I'll do on this as well, which is about the training data that goes into robotics and actually training. Depending on it could be it seems like it could be system agnostic to some degree, but to some degree it depends on what sensors the machine has and things of that nature. But I find it very interesting that there is a whole universe almost in terms of what it takes to train robotics and creating the training data for them based on whatever the user wants to perform or do at that point in time. And that is not something we're going to start talking about now, but I using it as a teaser to hopefully a future session on this topic, where hopefully we'll dive a little bit more in that. Well, but for now, as we're getting on time here, first of all, thanks to anyone who joined so far and tuned in and bared the wait there as we kicked off a little later than usual. But I thank you both for being here. So this was a fun conversation, and yeah, it's an exciting time. I think it's a bit under valued in terms of and very understated for where we are in this phase because there's a lot of planning that needs to go into this for sure. And so in that sense, I don't think it's too early for us to really look into this and consider realities that can be shaped. So
Oh,
yeah.
definitely. I mean, my, most of my time is spent in this space as hardware engineering for automation and innovation. I think there's so much opportunity here right now. And to be honest, we have a hard time finding hardware engineers. So I think it's going to continue to develop and over the next decade, and we'll hopefully start seeing some of the things we were talking about earlier.
Perfect. Well, in that case, Rex, any final thoughts?
It's a dynamic area. There are hundreds of companies, startups jumping into the field. It's going to be probably the most dynamic time in the history of manufacturing and logistics. Um, so anyone that's interested in joining the industry or working in the area, I think I kind of envy you just because you're at the very beginning. So I wish you the best and have fun.
Well, that baton gets passed even further as the generation goes further. So who knows, 40, 50 years from now,
Yeah.
what that next wave even looks like in that sense. But absolutely. Well, awesome. This was a pleasure. Thank you all. And as a final sharing of resource I have for anyone checking out the stream, I came across this recently. So Peter developed this Notion database for robotics companies, and there are hundreds of them there. And even from the ones that I've seen that I know are up and coming, some of them aren't even there as well. So on top of the fact that the many that are up and coming and are in market today are listed, so just speaks for the volume and momentum there is in the space. So feel free to scan that QR code and check out that database. But it was useful also for me just for preparing for this to kind of see what companies are out there and what all is everyone doing. So yeah, I thank you all for joining and very excited for what's ahead here and for future topics as well. There are quite a few things coming up adjacent to this and maybe less adjacent, but still relevant to the built environment. So thank you all for joining, and until next time.